So thermodynamics generally in our chemistry, we are having two parts. One is the thermodynamics chapter, okay, and the other one we are having the thermochemistry. So what is the difference between this one and this one? So I think you will have thermodynamics in physics also. In physics, we are calling it as physical thermodynamics, whereas in chemistry, we are calling it as chemical thermodynamics. For example, if you see work done on the system, in chemistry, it is positive, whereas work done by the system in chemistry, it will be negative. But if you go to the physics, in physics, what happens? Work done on the system will be negative, and work done by the system will be positive. So that is nothing but difference between the physical thermodynamics and the chemical thermodynamics. Because in physics, what we are doing nothing but we will work on the surrounding, but in chemistry, we will work in the system. Means in system, what is happening? So that's why there is a difference between the physical thermodynamics and the chemical thermodynamics. Whereas coming to the in chemistry, most of the questions will come from this thermochemistry only. Means thermochemistry, we are having the heats of reactions, heat of combustion, heat of neutralization, or heat of formations, and all those things. Also calorimeters and all those things we are having, as well as first law of thermodynamics also is very, very important. And different processes are just like adiabatic process, isobaric process, isothermal process. So all those are very, very important in thermodynamics. Okay. So we will learn about all those things and we'll go with the question wise. So first question, let's see. So given what is there? C graphite plus O2 gives rise to CO2. So delta H is given as X kilojoules per mole. Okay. C graphite plus half O2 gives rise to CO, and delta H is given as Y kilojoules per mole. Okay. The third equation is CO plus half O2 gives rise to CO2. So delta H is given as Z. So based on the above thermochemical equations, find out which one of the following algebraic relationships is correct. Okay. So what is the relation between X, Y, and Z? He is asking. Based on the options, we can see that he is asking the relation between X, Y, and Z. So first of all, suppose this is the equation number 1, equation number 2, and equation number 3. So now, if you can see, if we combine the equations, we will get some, suppose I am combining Y and Z. If I am combining 1 and 2, if I am combining 2 and 3, we will get the second equation is C plus half O2 gives rise to CO, and the third equation is CO plus half O2 gives rise to CO2. Yes. So if you are adding these two equations, you will get CO get cancelled, and you will get C plus O2 gives rise to CO2. It is nothing but that is first equation. Yes. So I can say that this is X, delta H value is X. This is delta H value is Y, and that is delta H value is Z. So from this relationship, I can say that X is equals to Y plus Z. It is nothing but one of the application of the Hess law. I think you know about the Hess law, that if any reaction is taking place in number of steps, then the sum of the enthalpies of all the equation will be equal to the what is that? The single equation. Yes, there is nothing but the Hess law is calling. Okay, moving on to the next question. So again, the C graphite plus O2 is CO2. Here delta H value is something as given, and H2 plus half O2 gives rise to H2O. CO2 plus 2H2O, CH4 plus 2O2. Okay. So based on the above thermochemical equations, the value of delta H at 298 Kelvin for the reaction. So the required equation we are having C plus 2H2 gives rise to CH4. So we have to see in mind that how to find this equation using these equations. Don't worry about this one. Don't worry about these values. We'll see afterwards. First of all, we have to find this equation from these three equations. So in the equation, I'm having C graphite. So C graphite will be like this only. In the whole equation, we are not having any O2. We are not having any oxygen. So O2 should be eliminated. We'll see how it will be eliminated. Next, we are having 2H2. So here I'm having H1H2. Okay, as well as I'm having CH1 CH4 molecule. Here I'm having one CH4 molecule. Means CO2, H2O, and O2 should be eliminated. So you can see here how many H2 is there? One H2 is there, but here two H2 is there. Half O2 is there, and here one O2 is there. So half O2 means O2, 3 by 2 O2. So if I am multiplying this equation, suppose this is the first, this is the second, and this is the third one. So if I am multiplying the second equation with 2, So I am getting that 2H2 plus O2 gives rise to 2H2. Yes. Now, so I am writing here 2H2 plus O2 gives rise to 2H2. Now 2H2O, 2H2O is there, O2, O2 is there, and C graphite CO2 and CO2 is. So if I'm adding all those three, so suppose this is the fourth equation I'm having. So I'm adding 1 plus 3 plus 4. So what are those equations? Let's see first of all. So the equations are C plus O2 gives rise to CO2, the first one. Next, the third equation is CO2 plus 2H2O gives rise to CH4 plus 2O2. CH4 plus 2O2. And the fourth equation we are having 2H2 plus O2 gives rise to 2H2O. This one only? Okay. So now O2 should be eliminated, and so what we can do is 2H2, 2H graphite, 2H2, 2H2O is there, can be eliminated. So let's see what happens. So here CO2 get cancelled, and H2O get cancelled. O2 2O2 get cancelled. So I can write C plus 2H2 gives rise to CH4. That is our required equation. Yes. Now what is the values? Let's see. Delta H is equals to. So what I am doing, first one is minus 393.5. So minus 393.5 plus 3. So plus 3. What is the 3 value here? Plus 890.3. So plus 890.3. Next 4. So fourth one, how much delta H value is this one? This will be 2 into 285.8. So 285.8 into 2, I can write 6, 1, 11, 1, 6, 17, 5. So 571.6. So I can write minus 571.6. So now what is the value? Let's see. 890.3. So this will be 6 plus 5, 1, 3, 4, 5, 9, 7, 6, 1, 5 plus 3, 8, 1, 9. So minus 9651 plus 890.3. So 890.3, or I can write like this, 965.1, 965.1 minus 890.3. So 11 minus 3, 8, 4, 16 minus 3, 7. So I will get answer as minus 74.8, minus 74.8 kilojoules per mole. So that is our answer. So how to find means nothing but in thermodynamics, something difficult will be there, because you have to know the mathematics very you should have a good command on the mathematics, algebraic equations, how to write all those things. Clear? So answer is our minus 74.8 kilojoules per mole. Next, the thermal dissociation of equilibrium of CaCO3 is studied under different conditions. Okay. So here given the required equation, nothing but the equilibrium equation he has given. For this equilibrium, the correct statement is or are. The first one is delta H is dependent on T. So generally we know that delta G is equals to delta H minus T delta S. Yes. Now at equilibrium point he is saying means delta G will be equals to 0. So I can write delta H is equals to T delta S, means delta H is directly proportional to temperature. So it is correct one. Next, K is independent of the initial amount of CaCO3. K is independent of the initial amount of CaCO3. What is K? Nothing but equilibrium constant. Now, in equilibrium constant, we will consider the solid as a unity. The concentration of solids as unit. So CaCO3 is a solid one here. So that's why K is independent of the initial amount of CH. It is also correct. Next, K is dependent on the pressure of CO2 given. For this equilibrium equation, I can write Kp is equals to pressure of CO2 only, because it is a solid and this is also a solid. So we will consider only for the gases. So K is dependent on the pressure of CO2. Yes or no? Yes, it is also correct. Next, Delta H is independent of the catalyst. See, whenever a catalyst is added, what is the work of the catalyst? To lowers the activation energy. The work of the catalyst is to lower the activation energy, but doesn't change the enthalpy value. It will not change the enthalpy value. Okay, it will lower the activation energy only. So delta H will be independent of the catalyst. So answer is our A, B, C, D. So all are the answers here. Okay, next one. Next, so diboron is a potential rocket fuel which undergoes combustion according to the reactions. So this is the reaction is given. Okay, from the following data, calculate the enthalpy change for the combustion of diboron. This is the combustion of diboron. Clear? Now, the 4 equations he has given. In these 4 equations, we have to find the required equation from these 4 equations. Okay, let's see. So first of all, B2H6 is there. So find where is B2H6. So B2H6 is there. So I will write this equation. I suppose this is 1, 2, 3, and 4. So fourth equation I will write as B2H6 gives rise to 2B plus 3H2. So delta H will be equals to minus 36 kilojoules mole inverse. So this is suppose our fifth equation. Okay. Next 3O2. Okay, 3O2. Now I am having how many O2? 3 by 2, 1 by 2 means I am having 4 by 2 O2. Suppose I am multiplying this equation into 2. So I will get as 2H2 plus, sorry, with 3 if I multiply, I will get 3H2 plus 3 by 2 O2 gives rise to 3H2O. The delta H value will be equals to 6 3 are 8, 24, 5, 2, 8. So minus 858 kilojoules per mole. These are our sixth equation. Okay. So 3 by 2, why I am multiplying with 3 means nothing, but here see 3 by 2 O2, 3 by 2 O2 will be equals to 3 O2. So I will get the 3 O2 here. Next B2O3. So I am having B2O3 here, and next 3H2O. So I am multiplying with 3H2O means that it is in the gaseous state. See here. So I am multiplying with 3. That's why I am getting the 3 here. Okay. Now 3H2O gaseous molecules are there, and here H2O liquid is there, H2O gas is there. So whenever I am having H2O liquid, H2O liquid should be eliminated. So no, I think this is wrong. So here should be liquid. So question is wrong. Here should be liquid. So now we will multiply this one with 3. This one with 3. Then we will get the required equation. Okay. So I will get the third equation as 3H2O gives rise to 3H2O gas. So I will get delta H value will be equals to 132 kilojoules per mole. So 3H2O gaseous molecules have 1. Also we have to multiply with this one also with 3 because of 3 by 2 O2 is there. So this one into 3. So I will get as 3H2 plus 3 by 2 O2 gives rise to 3H2O liquid. Delta H value will be equals to 286 into 3. So 286 into 3 I can write 8152 858. So minus of 858. Yes. Okay. So this is our sixth equation and this is our seventh equation. So now we will add all those things 1, 2, 1, 4, 5 and 5, 6, 7. So 1 plus 4 plus 5, 4 is there. Okay. 1, 2, 3, 4. 1, 4, 5, 6, 7th one. So 1, 5, 6, 7. Okay. So 1 plus 5 plus 6 plus 7. So what is 1 first of all? So 2B plus 3 by 2 O2 gives rise to B2O3. This is the first equation. Next fifth one is B2H6 plus, sorry, B2H6 gives rise to 2B plus 3H2. You can ask Viren in the chat box the doubts what you are having. Next 3H2O gives rise to 3H2O liquid. H2O liquid gives rise to 3H2O gas. And the seventh equation is 3H2 plus 3/2O2 gives rise to 3H2O liquid. So adding all those equations, what you will get? First of all, see 2B got cancelled. Okay, 3/2O2, 3/2O2 will get what is that? 3O2. Okay, that is okay. Next 3H2O, 3H2 get cancelled. 3H2O liquid, 3H2 will be cancelled. So I will remaining with B2H6 plus 3O2 gives rise to B2O3 plus 3H2. So this is the required equation, I think. So B2H6 plus 3O2 gives rise to B2O3 plus 3H2. Okay. So delta H value will be how much? So first one is minus 1273. Next fifth one is how much? Minus 36. Sixth one is plus 132. And this one is minus 858. So adding all those numbers, you will get the answer here. Okay, clear? So here, oh, I know that it's little bit difficult to find all those things and coming with the answers, because you have to do the calculation, because it is an advanced paper and you will get 18 questions from chemistry, 18 questions from physics, 18 questions from mathematics, nothing but 54 questions. From these 54 questions, you are getting 3 hours of time, 180 minutes. That's why it will take time to calculate all those things and you will get the final answer. So it is this one is the integer type question. So this type of question, it will be difficult to predict the correct equation, how to find the correct equation like that. Okay, it will take time. So sometimes a confusion will be there to find all those things. Even I will also confuse. I'm confusing nothing but, so you will also confuse to find all those things. Clear? Next, delta H vaporization is given 30 kilojoules per mole, and delta S vaporization is given 75 joules mole inverse Kelvin inverse. Find the temperature of the vapor at 1 atmosphere. So generally, we can write delta H is equals to, we are having equation as delta H is equals to T delta S. Yes, so I can write T is equals to delta H by delta S at vaporization. I am saying delta H vapor by delta S vapor. Okay, so delta H vapor is 30 kilojoules, and here see the units. Sometimes will be there, we will not find the units also. Here 30 kilojoules is there, 75 joules is there. So I will write 30 into 10 power of 3 by delta S is 75. So simplifying this, 3 into 3, 4, and writing 75. So 25 into 3, 25 into 400. So 3 got cancelled. You will get 400 Kelvin as your answer. So answer is nothing but the option A. So simply you can find the answer. It's a simple question, but sometimes here you will find the difficulty, kilojoules and joules. So you have to read the question carefully so that you can get the answer. Next, estimate the average SF bond energy in SF6. The values of standard enthalpy of formation of SF6, sulfur and fluorine are given. So first of all, so SF6 is having S plus 6F. Okay, so I can write delta H is equals to products minus reactants. So product is how much? Minus 1100. So minus 1100 plus, so not minus 1100. Sulfur is 275. So 275 plus Sulfurine is 80, so 60 into 80 minus SF6. So minus of minus plus, so plus 1100. So I will write there 275 plus 480 plus 1100. So you will get answer as 5, 8 plus 7, 15, 4, 5, 6, 7, 8. So 1855 kilojoules per mole I am getting. Delta H value. So he's asking me to find the average SF bond. So there is SF6, 6 SF bonds are there. So average bond will be equals to average bond energy will be equals to, since 6 SF bonds are there, so 1855 by 6, you can find the answer here. Okay, clear. Next one. So from the following data, calculate the enthalpy change for the combustion of cyclopropene at 298 Kelvin. The enthalpy of formation of CO2, H2O and propene are given. The enthalpy of isomerization of cyclopropane to propene is this one. So first of all, cyclopropane to propene. How much delta H is given as minus 33 kilojoules per mole. Okay. Now let's find the combustion of propene. So propene means formula is, or we will write propene. Okay. Propene formula is C3H6. So combustion means 9 by, because we know the formula is, general equation for the combustion is nothing but for hydrocarbons I am saying CXHY plus X plus Y by 4 O2 gives rise to XCO2 plus Y by 2 H2O. This is generalized equation for the combustion of any hydrocarbons. So C3H6 plus 9 by 2 O2 gives rise to 3CO2 plus how much? Y by 2 H2O means 6 by 2. So 3 H2O. So for this, the delta H value will be equals to, so delta H will be equals to, here 3 is there, and for CO2 and H2O is given as CO2 H2O minus 393.5 and 285.8. So I can write minus of 3 into 393.5 plus 285.8. For O2 it is 0. We know that because in the gaseous form for O2 will be, the heat of formation will be 0, and for propene the heat of formation is how much? 20.42. So minus 20.42 I can write. Okay, so this will be equals to 393.5 by 285.8. So 31976. So 679.3 into 3, you will get 9 and 9 3 27, 2 21 23 3 2 18 20. So 2 minus 2037.9 minus 20.42, that will be equals to how much? Minus, so 2037.9, 20.42. So 23185. So 2058.32. So minus 2058.32. So here delta H value is minus 2058.32. Now add these two, propene will cancel, and you will get the cyclopropane, combustion of cyclopropane you will get. Okay, so adding this one, we will get delta H is equals to nothing but minus 33 plus, and this is also minus, so minus 2058.32. So 0.32, 8 plus 11, 1, 5 plus 3, 8, 9. So minus 2091.3 kilojoules per mole. Okay, so this is the what is it? Enthalpy of combustion of cyclopropane. We are getting like this. Okay, so you have to go with all the calculation part, because in physical chemistry only calculation will be there. So more number of calculation you will get, nothing but it is just like physics only, because in physics also I think you will get more number of calculations only. So here also you will get more number of calculations only. Okay, so for the calculative part you have to be nothing but you have to be see that what are the calculations parts are there. Okay, next, the standard enthalpy of combustion at 25 degrees centigrade of hydrogen, cyclohexene and cyclohexane are given. calculate the heat of hydrogenation of cyclohexene. So required equation is, this is a cyclohexene. On addition of hydrogen, you will get cyclohexene. So I want the delta H value of this one. So what is the delta H value? Nothing but products minus reactants. So for cyclohexane is how much? Minus 3920.20. Minus 3920. For the heat of combustion, or heat of combustion is given, means nothing but we have to write delta H is equals to sigma of heat of combustion of reactants minus sigma of heat of combustion of products. So heat of combustion of reactant is how much? Cyclohexene and hydrogen we want. So minus 241 and minus 300. And for cyclohexane, products is 3920. So plus 3920, because minus or minus will get plus, nothing but. So you will get, this is how much? Minus 541 plus 3920. So 3920 plus minus 541. Okay. So 10 minus 1, 9. 11 minus 4, 7. 8 minus 5, 3. So 3 minus 3379 kilojoules per mole. Okay. So this is how we are finding the required equation here. Okay. Next one. Okay. Next is a passage. So when 100 ml of 1 molar HCl was mixed with 100 ml of 1 molar, and okay, the neutralization reaction is this one, in an insulated beaker at constant temperature. A temperature increase of 5.7 degrees centigrade was measured for the beaker and its contents. So this is experiment 1, where strong acid and strong base is mixed, and increase of 5.4. Generally, for 1 mole of strong acid and 1 mole of strong base, you will take the delta H value will be nothing but 57 degrees centigrade, something increases. Okay, but here 5.7 degrees centigrade is increasing, means nothing but we are having 0.1 mole of HCl and 0.1 mole of NaOH. That is clear. Okay, because the enthalpy of neutralization of a strong acid is strong base is constant, 57 kilojoules per mole. This experiment could be used to measure the calorimeter constant. Okay, we have to measure the calorimeter constant from experiment 1. Now, in a second experiment, 100 ml of 2 molar acetic acid, that is the K value is given, was mixed with 100 ml of 0.1 molar NaOH under ionical conditions to experiment 1, where temperature rise of 5.6 degrees centigrade was measured. Okay, so this is the, what is the, in the first case, what happens? Strong acid and a strong base is mixed. There is an increase of temperature of 5.7 degrees in the experiment 1. Okay. In the second case, second experiment, a weak acid and a strong base is mixed, means nothing but buffer solution will be formed. Okay. But the weak acid consists of 2 molar and the strong base consists of 0.1 molar only. Okay. So now this is not 0.1 molar, I think this is 1 molar. So 1 molar NaOH. So but now temperature is raised to 5.6 degrees centigrade. Now let's see what is the question. The question is enthalpy of dissociation of acetic acid obtained from experiment 2 is. Okay, enthalpy of dissociation of acetic acid obtained from experiment 2. So how to find? So let's see. Let C kilojoules. Let C joules Kelvin inverse be the heat capacity of the calorimeter. Okay. Now the mass of the solution will be is equals to, because 200, because you can see that 100 plus 100 means 200 ml we are having. So 200 into 1 gram milliliter, that is equals to 200 grams. So heat evolved. So first of all, we have to find from the experiment 1 the calorimeter constant. So heat evolved in experiment 1 will be equals to 57, because 57 kilojoules per mole is, because it is a constant value for a strong acid and a strong base. 57 into 1000 into 0.1 mole already I say. So you will get the heat as 5700 joules. So I can write 5700 joules is equals to 200 into 4.2 plus C into, since 5.7 degrees centigrade of temperature is increased. So that will be equals to 1000 equals to 2400 into 4.2 plus C. Now 24, no, it's 200, sorry, 200 into 4.2 plus C. Now let X kilojoules mole inverse of heat evolved in neutralization of acetic acid. Then we can write X into 1000 into 0.1 is equals to 200 into, here since 5.6 of heat is temperature is increased, so we are writing 5.6. So after solving this, you will from the this equation, from this is first equation, this second equation. So from 1 and 2, from 1 and 2, we will get X is equals to 56 kilojoules per mole. So enthalpy of ionization, I can write enthalpy of ionization of acetic acid will be equals to minus of 56 minus of minus 57, already we are having there, it will be equals to 1 kilojoules per mole. So see, this is a question which is related to the ionic equilibrium also. So ionic equilibrium, thermodynamics, both are combined here. So thermodynamics can be combined with electrochemistry, chemical equilibrium, ionic equilibrium, solutions also. So here means that the multi-conceptual questions will come from these chapters. Thermodynamics is added, means nothing but is combined with all those chapters. Okay, so here ionic equilibrium is combined here. Next, the pH of the solution after experiment 2 is. So we are having the CH3, the experiment 2 is telling that CH3COH plus NaOH gives rise to CH3COONa plus H2. So since in the question, in the passage you can see that 2 molar of acetic acid is there, 1 molar of NaOH is there. Means nothing but I can say there how many millimoles are there? 200 millimoles. Okay, and this is 100 millimoles initially. So after that it will remain as 100 millimoles, it will be 0 and it will become 100 millimoles. Okay, so I can write Ka is equals to or concentration of H plus into concentration of CH3COONa by concentration of CH3COO minus. Now since these two concentrations are same, so they will cancel out each other. So K will be equal to nothing but concentration of H plus. So I can write pH is equals to minus of log concentration of H plus. Yes, there is nothing but minus of log K. So K is given as already how much? 2 into 10 to the power of minus 5. So can write minus of log 2 into 10 to the power of minus 5. Or I can write pH is equals to minus of log 2 plus 5. So 5 log 2 is we can write 0.3. So you will get 5 minus 0.3 as 4.7. So pH will be equals to 4.7 we can write. Okay. Yeah. So that is the end of the questions from the chapter of thermodynamics or the physical chemistry part 1. So we will have with the part 2 on Friday and Saturday, part 2 and part 3. Okay. So thank you very much.